Okay, so working on these problems, these practice problems, I want you to kind of see if you can do them on your own first, and then check back here to see if you have the right answers. And so yeah, let's do this. Here we go. For problem 1, we have cosine x over 1 minus sine x is equal to 1 plus sine x over cosine x. And same idea, we want to prove that this side of the equation is equal to this side. So what we're going to do first, for an equation like this, is I'm actually going to cross multiply. So I'm going to multiply these two values and these two values. So we have a cosine x times a cosine x, going to give us a cosine squared x, and we have a 1 minus sine x times a 1 plus sine x. So next I'm going to distribute these so we can get to all of our individual terms that we're working with. So 1 times 1 is 1, 1 times positive sine x, we have negative sine x times 1, and negative sine x times positive sine x. It's going to give us a negative sine squared x. Looking at our terms that we have now, we can cross out and cancel those, a positive and a negative sine x. So we're left with cosine squared x is equal to 1 minus sine squared x, and aha! Because we know our identities and we are familiar with them, we can see that a 1 minus sine x, that's going to be our Pythagorean identity, and we know that that's going to be cosine squared x because we subtracted over our sine squared x and left our cosine squared x all on its own. So that one is done. Moving on to number 2. You'll notice that they used what's called a beta symbol in the place of either an x or a theta here. So instead of like cosine squared x, it says cosine squared beta. That's just another way to represent an angle measure. So nothing weird, just kind of like, you know, trying to trip you up with the symbols used, but you know, nothing new here. So we can definitely handle this one. So looking at what we want to do here, I'm referring back to my notes. It looks, so sorry. Okay, yes, so looking at what we have here, we have a cosine squared beta minus a sine squared beta, and if we look at the identities that we were given, we can see that a cosine squared theta minus a sine squared theta is equal to cosine of 2 theta. So we can substitute this numerator right here for this identity, our cosine double angle identity right there. So we have cosine squared beta and minus sine squared beta. That's going to become cosine of 2 beta over 1 minus tan squared beta is equal to cosine squared beta. So now I'm so sorry if I keep writing this out of the frame. But okay, so now we have our substituted value over our denominator, and then our original right side of our problem. So I'm still going to work on our left side here because that's our more complex side. But what I'm going to do here is try to get rid of this denominator because I like what we have going in our numerator that looks nice and simplified to me, but this denominator is tricky. So I'm going to bring it over here to our right side where we can work with it. So now I've multiplied by our denominator over here. Those two will cancel. Cosine 2 beta will carry down. And over here, when I multiply out and distribute, we're left with cosine squared beta minus cosine squared beta times tan squared beta. So looking at what we have now, we have one really good simplified term over on our left side here. We have a really good simplified term kind of there, but we're definitely going to want to work with it. But we can't really work with it yet because we have this big ugly term over here. So what we're going to do is try to work and get rid of that big ugly term. And to do that, we see that we have a tangent value. We know that tangent is rarely ever going to be left in an equation untouched. So we know we can substitute that out for our sine over cosine value. So I'm going to copy down the rest of the equation. When I get here, write cosine squared beta over 1. And we're going to multiply that because, again, it's a tangent squared beta. We manipulated the tangent, so we have to manipulate the sine and the cosine that we use to get the tangent. So that's going to become sine squared beta over cosine squared beta. And when we're looking at our terms here, our cosines will cancel out. So we're left on the left still with cosine 2 beta equals cosine squared beta. And then the only thing that's left from that multiplication is sine squared beta. So now looking at the right side of our equation again, we have a cosine squared beta minus sine squared beta. If we look at our potential double angle identities, we see that cosine squared theta minus sine squared theta, same format that we're working with in our problem right here. We see that that is in our cosine double angle identity. So we know that our left side here is also going to be a double angle identity, and those two are equal. So that's problem Q. Alrighty, moving right along here. So our problem 3 that we're looking at here, this one is actually one of the ones that kind of tricked me here. So, and I'll explain why when we get there, but so when we're looking at what we're working with here, we're multiplying. So again, what I was trying to do when I was first solving this is distribute, but if you notice, there's actually a simplification that we can already do. So if you notice in these parentheses here, that we have a 1 minus sine squared a. Again, we're not working with theta or x, it's just another variable that can represent an angle measure. So a is like beta that we used up here, it's like x that we used in this problem. It's just another variable. But when you're looking at what's in these parentheses, you have 1 minus sine squared a, or alpha, but I'm going to call it a. And, excuse me. But we know that that's one of our Pythagorean identities. And so we know that we can substitute cosine squared a in for that value. So we write down the rest of our equation here. But this is going to become cosine squared a, because from our Pythagorean identities, when we subtract our sine over, we're left with cosine squared a on the left side. Okay, so now looking at what we have again, now that we've simplified all we can simplify, with what we were given. Now I'm going to move on to distributing. So we have 1 times cosine squared A, it's going to be cosine squared A, plus tangent squared A times cosine squared A, and those equal 1. Looking on to what we want to kind of do with what we have now, again, a tangent is very, very rarely ever going to be left in a final solution. So I'm going to work with that tangent value, copy down my cosine squared A. My tangent squared A is going to become a sine squared A over a cosine squared A, and we're multiplying that by a cosine squared A. I'm going to put that over 1, and we're still equal to 1. So looking at our multiplication problem here, we have a cosine squared A that can cancel out. And we're going to copy down. The only thing left here is a sine squared A. And when we look at this, we've actually just solved our solution that we have here is equal to the Pythagorean identity, which is sine squared plus cosine squared equals 1. Here we have cosine squared plus sine squared equals 1. So we know that this side will equal 1. And that checks out. So our last problem for this page is sine x over tangent of x is equal to cosine x. This side is really simple, so I'm going to work with this side. We have sine x, and I'm going to put that over 1 because we can see that the only thing that we can work with and manipulate on the left side there is that tangent. So we're just going to go straight for that, straight for manipulating that tangent value. So I'm going to leave the sine x, I'm going to put that over 1, but because we're dividing by tangent, as I've said in the past, I'm going to multiply by the reciprocal. So I'm going to put the denominator on top and just multiply because that's the equivalent of dividing. So our cosine x is going to be on top, and our sine x value is going to be on bottom. Copy over the right side. Our sine x values will cancel. And we're left with cosine x equals cosine x. So there you go. You've now been introduced to all 3 types of problems for trigonometric identities. So our next practice sheet that we're going to work with is what I believe your quiz will probably look like. It's mostly going to be those second 2 types of questions. And so I will go over all of those. I will also send you a picture of these, and I'll upload pictures of them to the Google Drive folder, so you'll have access to them there too. So good luck. Try this next page on your own, and then watch the video to see how you did, as far as if our strategies match and if your answers match. More importantly, if your answers match.